Okay, so today we'll learn about the global sizing and the local sizing, how we perform in ANSYS measure. Okay, so this is the geometry. This geometry is of T. Okay, so we'll do a meshing which is required for the CFD. So first of all, what we have to do, we have to select the mesh, and when the dialog box of mesh is open, there is a physical preference. In the physical preference, what we have a one option called CFD, and we want mesh related to the CFD. So we'll use that physical preference, and then we can use the solver like Fluent, Safest, and Polyflow. So we can choose any of the one solver for the meshing. As the requirement of solver, what solver we are using, we can switch between the Fluent, CFX, yeah, Polyflow. Okay, so today we learn about the global sizing, how we do a global sizing, and the next part is local sizing. So basically, global sizing is what which we control the mesh from this dialog box. That is the local sizing, and the one which we go locally and control the uh, method and sizing. So over which we have to go locally and select any of the face. Okay, and then select the sizing that comes under the local sizing. Okay, so this is what I have given the overview of local sizing and the global sizing. The global sizing we are covering for which is controlled by the mesh dialog box, and local sizing which you go individually to each of the faces and we can control locally. So first of all, this solver I have selected and the physical preference I selected. Now I will generate the mesh in ANSYS measure. Okay, so this mesh has been selected. It's a very coarse mesh. So how we can apply the global sizing first, that we'll look into it. Before that, we'll analyze the mesh which is distributed on this geometry. So you can see at every curvature we have a little bit fine mesh, and as we saw under this T, we have a coarse mesh, like this coarse mesh on the surface. So that is what is our requirement, that we have to make it a fine mesh, resolve is better, so that we can easily apply the solver and we can have a very reliable solution. Okay, so let's see the mesh when we use the cut plane. Okay, see the mesh inside the T. Okay, and we can see over here that the mesh along this thickness we have very coarse mesh. Okay, you can see the elements are not very much well distributed, and similarly on curvature also you can see it's very fine, not that much fine mesh. So hence we can say that with this mesh we cannot have a very reliable solution, or we cannot trust on the solution. Either we can get a divergence, or else we can have a divergence, or not. We can face a problem of convergence issue. Okay, so let's apply first global meshing. And the global meshing, uh, we can control use using the first element size. So right now the element size 2 e to power minus 2, we can reduce it to the 1 e to power minus 2. That is what we are globally distributing on the geometry. Suddenly, sudden, suddenly, you can see the meshes we need to generate over here once again to see what is happening. Along with this, right now we have a sizing. We can control the curvature. Okay, and because this is a geometry which is very much related with a very have very much curvature. So we can use curvature as we have option of curvature, so we can capture the curvature, and this curvature angle we can decrease it, as I told that as the curvature is angle is we are decreasing to 12, 13. So this angle is spanned by inside the curvature, and once we decreasing the angle, we can have a much more fine mesh in that region. So right now it's 18, we can decrease it to the 16 or 15. Okay, so this is what we are controlling the curvature. And the next, we can have a fine mesh in this region also, or inside the like which have a thickness. So that thickness we can control using the proximity. So right now there is a no proximity. We can turn off the this thing, and then we can have a proximity, and the proximity is telling that there is a three elements should be distributed along the thickness, so we can increase it to the four, okay, for better resolution, or else we can keep it as a default three element along the thickness. Okay, in that thickness part is very much good, so we can keep it as a three also. Okay, and then you can have a preview also. We can have a preview of surface mesh. Okay, and else if you don't want to see a preview, you can directly generate the mesh also. Okay, so let's wait for generate the mesh. This is something that we have done a global sizing that we are controlling from the tab of mesh. Okay, now we can also use over here local sizing. Okay, that I will tell you once this mesh is generated. Okay, so this is something preview we can do. This is how well distributed you can see now. It's very much fine, and then you can click on generate the mesh for a final look how it is there. So right now we have seen the preview. Now let's move for the volume mesh, how it is distributed. Right now the main focus is that to make a very much appropriate mesh, but as as we grow in a CRT, when we learn the solver, so solver also have demand that we cannot have a so much fine mesh, because fineness of mesh we can achieve by the software, but if we keep make the mesh much more fine, then our result of a solution will take a lot of time. So we always make a optimized decision that the resource should not be so much consumed, and at the same time we should get the results faster also. So that is what the requirement of it is. So we always optimize. So we have to do a trade-off between the fine mesh, as well as that fine mesh should not consume so much computer resource. Okay, so that thing we have to. So now you can see I have decreased the element size. The globally it has distributed on the geometry, and it has kept so much fine. Now on curvature also is well distributed. We have very much small element, that is also fine. Now once we are looking to this section view, and in a section view I told that there should be a four element. So you can see now it has distributed a four element along this side. So based on the what element size we have, it is a more than four, but it is always a more than four. Why it is more than four? Because we have also given the element size very small. So based on that, elements are coming more in this part, but that is a good sign, because we always want to capture if we have such kind of geometry, if the thickness along the thickness we require could mesh. So this is one of the option called proximity to control that part. Okay. Right now, this is what I have control locally. Now we can use in this local sizing also. So how we can use the local sizing? Let's see that part. I can select, although uh, in this what we can do, we can decrease it. We can increase this element size. Okay, and we can use the sizing, and sizing should be controlled in this way that this and this should be a fine. And right now there is a 2, but we can make it to 1 e to power minus 2 because we have over there we have made it 2. Now we have just given this a special surface to 1 e to power minus 2. So this is called locally controlling with the, because if this over here we want a good result, so if we are controlling this, if we are making fine, so in this way we can locally control this face sizing over here, and we are generating the mesh. Okay, now you can see the mesh in this region is also so much fine, and along this side it is a, if you see the compare these two faces, this face and this face, we have much more fine mesh on this region as compared to this and this and this part. Okay, so that is what benefit of local sizing. We can easily control the element size on a particular region, which is very much important for us. Okay, so as long as this is very is important, we can see some more useful part in this, like a sphere of influence, which is also useful, that if we want only a particular region to be fine. Okay, so we can use the sphere of influence. So how to use sphere of influence, I will share with you. Right now we have done, we have selected this part. Okay, so first of all, for sphere of influence we need to have a coordinate system, and we need to create a sphere. So we'll create one coordinate system. Okay, and they will ask us what should be the origin of that sphere. So right now we are selecting with geometry selection, or we can have a global coordinate. Let's control with the global coordinate, this coordinate system. This is 0, 0, 0. Okay, right now we can have a, if we put a number. Okay, so this is what the number. Okay, we are have the coordinate system, one more coordinate system in this region, and then we can, so this is one of the coordinate system, we can rename it. Okay, so this is what for face coordinate, for face sizing, we can give this name of face sizing, this coordinate we have made. Right now we have selected face sizing, and in this face sizing we can switch off this one face. Okay, and say this, I want only this face to be controlled, and in this we can use a sphere of influence, and So in this also phase, we are controlling only the sphere of influence where we'll create this sphere. It will only make fine in that region. Okay, so it should be the phase sizing coordinate system, and the radius should be the 0.5. Let's see, it's so much big. Right now you can see it's so much big. This sphere has been generated, so we have to reduce it to 0.05. So this is only the reason that we may have to make a fine. So we can also reduce the size to have a better refinement. Okay, so once the radius has been reduced, so on this phase we are only influencing this part. This is the local sizing using the sphere of influence, and we want element should be much more fine in this region, so we can easily look that part. So in this way, we can have a local sizing also and global sizing also. And in local sizing also, you can have a particular region. You can make it much more fine if it is a requirement. So that is thing possible with the help of sphere of influence or body of influence. Okay, so using that option, you can control a particular region to make it so much fine. So in this part, so things get done in this part. Have a coarse mesh in this region, and right now I just turn off the advanced size function like curvature and proximity to the for generating this phase sizing is similar that we require because so yes. So as of now we have to see that we can see that this part where we have set it up the sphere, okay, it is been so much fine as compared to the other phases where the mesh is distributed. So this mesh is very much fine as compared to the neighboring cell. Okay, this is called sphere of influence, and this comes under the local sizing, and this is used only where the if you want to make a find a particular region in the body, so we can use a sphere of influence. Okay, so sphere of influence can be used by the A sizing, vertex sizing, phase sizing. So on this we can use the sphere of influence. For body, we can use the body of influence. Okay. Hope earlier when the advanced size function was turned on, curvature and proximity, so algorithm got confused because it has to capture the curvature also, and as well as it has to do the fine mesh in on that curvature. So whenever we are using advanced size function, sphere influence property does not work. So whenever we want to apply a sphere of influence, we have to turn off the advanced size function like curvature and proximity. So again, we can make it much more fine for much more so that it look much more better, and we can generate the mesh. So this is one of the exercise that we have done with the T geometry and global sizing and the local sizing. Thank you. Thank you for this